Algebra 2. Today we're going to continue notes on factoring. We have already done the GCF method, greatest common factor. We also have practiced difference of squares, and recently we've worked on trinomials. Today we're going to look at grouping. Grouping is a factoring method that you use when you have 4 or more terms in your problem. So that's what you'll expect in all these types of questions. So here's where you'll need to start writing for notes today. Grouping method, again, has just what I said, 4 or more terms. And your goal is to find 2 pairs of terms with a GCF and then group them together. So you may have to rearrange the problem, but the goal is to look at all 4 terms, pick out 2 pairs that you know have a greatest common factor, write them side by side, basically do a GCF, and we'll have to do that twice in one problem. When you do the GCF for both pairs, then you're going to look at what is left in the parentheses. If the parentheses match and you have the exact same factors, then that means you are on track, you are doing it correctly. Again, you'll have 4 terms, you'll scan your problem, you may have to reorder it, but you're looking for 2 pairs of terms that you know have a greatest common factor. You're going to group those together, write them side by side, is what I mean by that. You're going to find the GCF, and then after doing so, what is left in the parentheses, if those factors match exactly, then you are on the right path. Okay, we're going to look at example 1 right now. And as I scan my first problem, I notice there are 4 terms. This is a polynomial. On those 4 terms, I notice that the first 2, especially, I definitely see a GCF because I know 2 goes into itself and into 6, and I'm also noticing that both of them have an A. So I'm going to choose to just put these 2 together in a GCF problem, and then I will do a GCF for this as well. Okay, often there's more than one way to see it, so I'm going to do it this method and then I'll show you another option. With the first 2 terms, just like what I said a second ago, I noticed that 2 and A is common in both of those. So your eyes are only on the first 2 terms right now. 2A times something will give you 2AK, and that's going to be K. 2A times something will give you negative 6A, and that's just going to be a negative 3. Alright, next I'm going to move to the last 2 terms, and the number I see is a 1 and a 3. 1 is the only number that goes into both. I'm also noticing that K does not show up in both terms, so in this case 1 is the only GCF I'm finding. And if it's 1, in grouping problems you will have to show it. 1 times K is K, and 1 times negative 3 is negative 3. Now, a second ago, I told you to look at 2 terms, find a GCF, and then if the terms inside parentheses match exactly, then you know you are on the right path. And so notice that mine do. K minus 3 is common in both parts. What I like to do is put a little bracket around each of these, like leave the plus sign in between to kind of separate it. And as I look at both parentheses or both brackets, I do notice that this is what they have in common. So now I am going to do another GCF. So grouping is nothing more than just doing several GCF steps. Now the new GCF is the K minus 3 expression, or this binomial. So I'm going to use parentheses around it. This is my new GCF. And then if I factor out k minus 3, then I'm going to do distributed property backwards. So again, all we're doing is GCF. K minus 3 times something is all of what's inside the first bracket. And so 2a times k minus 3, what's missing is the 2a. So in other words, this times this is all of this. K minus 3 times something is 1 times k minus 3, and that's going to be just the 1. And so for example 1, this would be the right answer. K minus 3 times 2a plus 1. Okay, what I want to do, and I'm going to kind of move over here, I'm going to write the same problem down for number 1 to show you that you do have choices here. Sometimes there's more than one way to group the terms. And so this time, what I'm going to choose to do is put this one and this one together, because both of them I see have a k. So I'm going to rearrange it just for a minute. Then I'm going to bring down my negative 6a and my negative 3. Let's focus on these two. GCF for 2ak and k is just going to be 1k. K times 2a is 2ak. Got my plus sign down. And k times something is k, and that's just going to be a 1. And you do have to put the 1 there. You can't leave it out, because if you did leave that out, then you wouldn't, by distributed property, you wouldn't be able to get the same piece back. And then I want you to focus on the last two terms. Negative 6a minus 3. Well, one thing I noticed that they have in common is both of them are negative, for sure. So I'm going to go ahead and use the negative as part of the GCF. And I noticed that 3 goes into both of those values. So I'm going to pull out a negative 3 for the GCF of the last two terms. Negative 3 times something is negative 6a. Negative 3 times 2a is negative 6a. Then I'm going, well, I factored out the negative. I got to be careful here. Negative 3 times something is negative 3. So I'm not allowed to just drop this sign down because I used it on the outside. So be careful what your signs, signs when you're doing the distributed property. Negative 3 times positive 1 is the only way I'm going to get back this negative 3. And then likewise, I want you to focus on the inner parentheses and notice those match exactly. And again, that's what we want to happen. And then I'm going to do the bracket like I did the last problem, leave the minus sign in the middle to separate the brackets. And now there's two parts to this problem. Both the parts have a 2a plus 1 in common, so that becomes your new GCF. You're going to put that out in front, and then you're going to figure out what's missing. I'm going to drop my minus sign down, and we'll fill in the blank. 2a plus 1 times something goes here to give me everything in this first bracket. And so I notice I had the same thing, and the only thing I've left out is the k, so k has to go there. 2a plus 1 times something is 3 times 2a plus 1, and that's easy, should just be 3. And so when I look at this answer, I'm seeing 2a plus 1 times k minus 3. When I grouped the first two terms, and I did it the first time, I got k minus 3 times 2a plus 1. So notice that this answer is exactly the same. It's just my factors are turned backwards, but that's okay because multiplication is commutative. The commutative property allows me to change the order of factors and still get the same product. So I did that example 1 two different ways to show you that there's not just one way to order these terms. So hopefully you got the point there. All right, we're going to move to example 2. In example 2, we're going to scan the problem, and we're looking, we see 4 terms right now. We're looking for 2 pairs that we know have a GCF. This jumps out at me. They both have a 2. And then I'm going to look at the first 2 terms, and I notice that they also have something in common. So I'm not going to rearrange this one. I'm just going to work left to right. With the purple terms here, I'm going to notice that both of those have an x, so I'm going to factor out x. X times something is x squared. Drop down my x. X times something is xy. And I'll drop down my y. And you can, again, check it using distributive property. Make sure it matches this exactly. Then I'm going to move to the terms I've underlined in red. I notice both of these have a 2. Now the signs, notice, are different. So here, you're just going to have to kind of guess and check. When they're different, I usually try the positive first and see if it works. If it doesn't work for me, then I'll go back and change it. So I'm going to pull out a positive 2. Positive 2 times something is positive 2x. Positive 2 times something is negative 2y. That's going to be a negative y. And I know I'm on the right track because, again, the inside parentheses on both of these are exactly the same. And that is good. So now, here's the 2 parts to my problem. Both of these brackets have x minus y in common, so we're going to use x minus y as our GCF. Okay. You can use parentheses here if you want instead of brackets. That's up to you. X minus y times something is all of this in the first bracket. And so again, this is a repeat. The only thing that I don't have right now is the x, so that's what goes in the blank. X minus y times something is 2 times x minus y. Well, it's got to be a 2. And the sign's positive, so I'll keep that sign. So my answer for example 2 is x minus y times x plus 2. Or, if you do it differently than I do and you rearrange it, then your answer may be backwards. Maybe you have x plus 2 in front and x minus y behind. But again, that doesn't matter, and that's completely left up to you. So you have choices. All right, let's focus on number 3. Go. And on question 3, I'm seeing a 6n to the third plus 3n to the second plus 8n plus 4. As I scan all 4 terms in my problem, these 2 appear to have a common factor. And the last 2 actually do as well. So I'm going to choose not to rearrange this. I'm going to start with the first terms. 3 will go into 6 and 3. This term has n to the third, this has n to the second, so they both have n to the second in common. Okay, we're doing another GCF. 3n squared times something is 6n to the third. 3 times 2 is 6. N squared times n to the first is n to the third. Next, 3n squared times something is positive 3n squared. And so I need to drop down my plus sign, and I've got to put that 1 there again because 1 times 3n squared is itself. I have to have a placeholder. Last 2 terms, I notice both of these are divisible by 4. Also, I notice the signs are both positive, so I'm going to use a positive 4 as the GCF. Positive 4 times something is positive 8n. You'll fill that in. Positive 4 times something is positive 4. Throw in my bracket. And I want you to look inside the brackets for each one. Both of them have this in common. And so now that's my new GCF. So we'll put that out in front, just like the others. And we'll finish it up. 2n plus 1 times something is all of this. That's going to be that 3n to the second. See how it comes down. 2n plus 1 times something goes here to make this match, and that would just be the 4. So there's my final factorization. 2n plus 1 times 3n squared plus 4. Okay, and I probably should have said this earlier, but when you're doing this process, it also wouldn't be a bad idea to look at your answer before you call it quits and make sure this doesn't factor any further. Like, for example, there's not a GCF in that, or no difference of squares, and obviously that's not a trinomial. And same deal here, there's no GCF. It definitely does not have 3 terms, so it's not a trinomial, and also it's not a difference because there's a plus sign. So keep that in mind, because I've seen problems that have, after you do grouping, still require some work. Alright, we'll end today's notes with this last one. I've got a 2x to the second plus 6x minus x minus 3. Okay, I think I'm going to stick with the first two and the last two. First two, I notice 2 is in common, as well as x to the first. 2x times something is 2x squared. That's just going to be x. And 2x times something is 6x. That's going to be 3. Then with the last two terms, I notice 1 is the only thing that goes into 1 and 3. Also, there's not an x in this term. But both of them have a negative, so I'm going to pull out the negative 1. That appears to be the only GCF for the last two terms. Negative 1 times something is negative 1x. Negative 1 times something is negative 3. Negative 1 times positive 3, what's your signs, is a negative 3. These match, so you continue. X plus 3 becomes your GCF. X plus 3 times something is all of this. And x plus 3 times something is all of this. And that looks like it's it. I've done 4 with you right now. Just know that if you do, on the process of solving or trying to factor these, if you do end up getting a different binomial on the inside, then either you've made an error on the sign, or you may have just chosen the wrong factors, because sometimes there is an incorrect way to do it. So just be careful. If these don't match, in other words, go back, start over, and pick 2 more pairs of terms. Okay, so today we've done grouping method for factoring. It requires you to look for GCFs multiple times on pairs of terms, and to know that all these problems we're focused on right now are going to have 4 terms up front.